All right, so we're gonna spend a little bit of time talking about something that is technically not malware, but it is suspicious and weird, and it's something I actually wrote about recently in a blog post. So it's this PDF viewer that accepts a specific PDF, and it then uses a key. This is the link that makes it suspicious. It uses a key that was seen last year in Rust Bucket campaign that was attributed to DPRK, and this key is used to decrypt an embedded PDF inside of the PDF to then show this PDF to the user. Um, so that's kind of weird. There's nothing that's dropped by this viewer like we've seen in the previous like Rust Bucket campaign from last year, but it is interesting and it allows us to talk about some Swift stuff, which is cool. So we're going to focus a little bit today on heap objects in Swift, and there's two calls that are really interesting that I want to talk about, and that is we're going to scroll down. So this PDF, let's actually drag this over. This PDF reader, it sets up an NS open panel so that when it's open, you can select a file to open or to view with this application. And it calls this set allowed file types method, and it passes this method to the NS open panel. And this accepts an array of strings or NS strings for the types of files that this will be able to open or can be selected in the NS open panel. And I set this to PDF because that's what we'll see in a moment, right? So if we go up and we look at what this value is, we'll see this incredibly long call to some stuff here related to Swift. So this is the function that we're going to focus a little bit more on because it's pretty interesting. And it is a Swift init static object. This is going to return a heap object, and it takes in metadata about this object, and then it takes in a pointer to this object that's in the binary itself in this case. So we have this call to instantiate concrete type for mangled name, and that's passed this demangling cache variable. Let's say, so this is just to say that this is a contiguous array storage of strings. And we have the actual location of what this object is in the binary here that's passed alongside this metadata. So if we double click on this, I actually changed the way that this looks a little bit, and we'll see the string for PDF here. So going back, this is going to create a Swift array with one element that is the Swift string of a PDF, and it's going to then use this array.bridge to Objective-C to convert that Swift array with that one Swift string into an NS array with that one NS string. And it's going to pass that NS array to this set allowed file types. All right, so that's the first thing we're going to look at. I'm going to drag this over, and I'm going to drag this over because it's a lot prettier to see this in disassembly. And I'm going to start our LLDB session. So this application is called dedicated PDF viewer.app. Already suspicious in my opinion. And we're going to process launch-s. And we're going to set a couple breakpoints here so that I don't forget to do this later. So we have this function here that we're looking at, this appdelegate.open. So I have that breakpoint set for the start of that function. Set another breakpoint for the call to this static init. And then we're going to look at, if we have time, we should closure. And then the key that I mentioned which is pretty interesting. All right, cool. So now we have our 4 breakpoints, and we're gonna hit continue. So this is that PDF, the dedicated PDF viewer or reader. It's called protected PDF viewer, and we're going to press this open button, and then that's going to trigger our breakpoint. Okay, cool. So let's just kind of move this over. We'll be able to select the file later. Okay, so we're at the start of this open function. We scroll up just to confirm where we are. It is 9324, 9324. Okay, so now we're going to press C for continue to go down and hit this breakpoint so that we can focus on the InitStaticObject function, which is right here. So 3C8. So continue. All right. We hit that breakpoint. So we can look at this here and we can see the different arguments that are passed. So we have this demangling cache variable that then is going to be passed to this Swift instantiate concrete type from mangled name. And then that's going to set up and create the metadata that's going to be passed alongside with this, which this pointer is, again, that PDF string, which is a Swift string. Okay, so we can actually look at those values. So the first argument is going to be an x0, and we'll see this full type metadata for Swift contiguous, very long, but basically a contiguous array of Swift strings. We can also look at some more stuff about this if we wanted to. And then this is going to be related to the metadata. That's funny. So PO, print object. So this is just a contiguous array storage. And we can look into this more another time, but there's metadata is really interesting when it comes to Swift. So the next register, or the next argument that's passed in, is going to be an x1. And this is going to be our outline variable number 0 of OSX PDF viewer.app delegate. And it's just basically saying that this is going to be that outline variable. And we can take a look at this. Okay, so this is going to be that pointer of the actual object that's in the binary that's then passed to this Swift InitStaticObject. And if you look closely, if you're used to seeing ASCII represented in hex like this, you'll be able to see these values here, which is going to be for the actual PDF string. And this is a Swift string, so it's 16 bytes long. And you can see on this side of this, plus 0x8 from the start of this Swift string, we can see that it represents 3 bytes, which is what we see here. So if we just look at this by itself, we'll see this is PDF. Okay, cool. So we know the metadata is being passed in x0, and a pointer to this object in a binary is being passed in x1, and then it's going to call this function with the branch and link instruction. So we're going to press next so that it completes that, and then we'll be able to see our static object in the return of this function, which will be an x0. So this is it. If we look at that in memory, we'll see there's some more things that were added in here. At first, when we looked at this, we saw there were zeros at the top of this, right? So at the start of this object. Now we have some metadata related to this. So if we look at this, we'll see that this is a contiguous array storage, which we would expect. We have the count here, which is at plus 0x10 hex capacity here, which is count times 2. And then the actual first element of this array is going to be at So this is 0, this is plus 10x or hex offset, and then this is plus the offset of 0 or hex 20. Okay, so that's 16 bytes away from this one. So we can, again, if we just look at this, it's what we expect. Okay, so what's going to happen next is the return of this, which is that Swift array, is then going to be passed to this array.bridge to Objective-C, which ends up creating that NSArray. So next, this is going to load the type metadata for the Swift string. Swift strings are structs. So it's going to load in metadata for a struct. We can actually take a look at that really quickly. So that was in X1. So this is metadata for a Swift string, which is a struct, and we can view information about it. This represents that this is a Swift struct. Okay, so now I believe we should be able to see, since this is metadata calls at the offset of negative 0x8, so -1 pointer value, we'll get to what's called the it's basically a v table of different functions related to this type. So we can actually see that really quickly, which is pretty cool. So -0x8 is this. And then if we look at this pointer value, we'll see different addresses for different functions for this type. And we can actually look at that. So we do like a quick image lookup -a, we'll see that. So this is this function, initialize buffer with copy of buffer, and this is for the value witness table that we're looking at for different functions to deal with this type. So that's kind of how metadata for types are used, so that Swift knows how to deal with this type. So that's why it queries for different metadata, and you can take a look at a bunch of these, and then you'll see different functions for different things. So this is like a destroy for the Swift string, but yeah. So just to go back to where we are, this is then going to create this NSArray, and that's going to be returned in X0. And let's see that in action. So if we look at X0, we can see that this is on the heap. And then we might be able to print this out. Yeah. So this is a Swift deferred NSArray. This is the address of this, and then it has that one NS string with the PDF value. Okay, so that's going to be passed or moved. This return value is moved to X20, and then that's going to be passed in as the argument to the set allowed file types. So let's just look at that really quick. So next, that was moved. Now we're going to load this string set allowed file types, which is going to be the method that's passed to the class in X0. This is Objective-C now that we're looking at. So let's go all the way to the call to Objective-C message send, which is going to actually send this method along with the argument to the class in X0. All right, so now we can look at those values. So it's going to be regread X0. This should be our class. Yes, NS open panel class. And you can see different options here. Right now we have this allowed content types. There's nothing in that. And we'll see that change in a moment. Okay, so this is the method that we're passing, set allowed files. And then the actual value in X2 will be the argument that's passed in, and that is the PDF. So then when this finishes, let's grab. So it's this. Let's just grab this. Next, we'll see that get changed. Now we have PDF as the allowed content types. Okay, so that's for this init static object, this Swift string that's inside of this Swift array that's passed after it's converted to an NSArray to the set allowed file types. So now if we continue from here, we should hit this closure, which I'll talk about here. So the way that this is handled, once that's set up, we have this begin with completion handler, which accepts a block, and this block actually has a closure inside of it. And then if we go in here, we'll see this is a partial apply for closure 1. If we go here, this is going to return closure 1, and this is where all the rest of this happens. Okay, so let's break there. We're going to hit continue. All right, so now this actually opens up this NS open panel, and we're going to select the actual document that it's expecting, which is this one. We're going to click open, and now we're inside of that closure because we set up that breakpoint. So the next thing I want to talk about is, if I can find it, this address, the initialize. So we're going to close this. We're going to use a G, so I can find this much quicker. 10000 C5 C4. Okay, that's going to be all the way inside of this decrypt data that's going to accept the encrypted PDF inside of this PDF, and then it's going to get this key. So we're going to just look at another init static object. So the way that this one works, very similar to the other one, is we have this Swift instantiate concrete type from angle name, and this one's a little bit different because it's not a string. It's actually going to show up as a uint8, and this is going to be that in the binary, and this ends up being the actual key that's used to decrypt or decode the embedded PDF inside of the PDF that we open. That's what that's going to look like, but we'll be able to see it in LLDB a little bit better, which is pretty cool. So let's make sure that we have this set up. So we're going to hit continue. Okay, so we're now at that other init static object. So we can see reg read 0 is this full type metadata for Swift contiguous array that's going to have these values, this uint8. And then we know that the address in x1 is going to be for this encrypted data, the key that is going to be used. So we're going to look at this really quickly. So we know from what we've seen before, the value at this from the start, the offset of 0x10, so 16 bytes away from the start, is going to be the count. So this is 64 bytes long, which is 100 in decimal, and that's going to be the length of this key. Okay, so now we're going to hit next, and that's going to return that value into x0. So this is going to be that address, and we're going to have that basically the header of this object. The first 16 bytes are going to have different things that we saw from before as this is initialized. This is going to tell us that this is a contiguous array now of this uint8, and then we have the 64 hex 64 byte key, and we can see the entries of this key here. We can actually also do like a count to see the entire key. So these are all the values for this key. And then that's going to be used to decrypt this. So if we were inside of the decrypt data function, this is then, if we finish this, we're back from the start of this data. So we can go to what called this, the caller, click finish, and this is inside of the get protected PDF data, which I renamed, and then it's going to be returned here, which will then be the result. We should see that in X0. So reg read. Okay, so this is going to be the length, and this should be all those bytes that were decrypted. So this length is a really big document. Don't remember how big this is, but you can just, if I can spell, script 0x. So that is 636,000 bytes inside of this this buffer here. Okay, so that's going to be the actual PDF. We can look at that. Okay, and it's going to be here. So this is going to tell us what this value is. This is a data storage type. So that's going to be the metadata at the top of this storage. This is going to be the length. So this is going to be where the actual bytes are. And then let's do, oh, this one. Okay, and then we can see there the PDF magic bytes. So that's going to be the PDF that's then presented to the user after it decrypts it using that key. And if we just continue, we'll see that that is what actually is presented to the user after they open this cryptocurrency thing, which is not super interesting. But the fact that this was inside of a PDF and it needed the same key is interesting, and it allowed us to talk about some Swift static objects. All right, well, that's it. Thanks.